So now, after all these steps, we have obtained a system of algebraic equations with unknowns u1 prime and u2 prime, and the matrix of this system is precisely the Wronskian matrix. So the determinant is the Wronskian, and it is non-zero because these two functions, t times e to the minus 3t and e to the minus 3t, were chosen to be linearly independent solutions of a homogeneous second-order linear differential equation. So the next step is going to be to solve this system applying Cramer's rule. I hope that you remember Cramer's rule, but even if you don't, you can quickly look it up, or you can just watch me doing this. So solve a system of algebraic equations, a linear system. What we are going to do is the following. We are going to form a ratio. The denominator is going to be the determinant of the matrix of the system. So in this case, is the Wronskian matrix, is t e to the minus 3t, e to the minus 3t, t e to the minus 3t prime, and e to the minus 3t prime. And the numerator of the matrix is the same matrix, only since we are finding the first variable, we need to replace the first column with the right-hand side of the system of algebraic equations. So the first column is replaced with 0 and t square, and the second column is the same as e to the minus 3t, e to the minus 3t prime. Okay, so now the numerator is easy, is just minus t square e to the minus 3t. Denominator we have to calculate. So let me find the derivatives finally. Et times e to the minus 3t. Here I'm going to have e to the minus 3t minus 3t e to the minus 3t. E to the minus 3t minus 3 e to the minus 3t. Okay, minus t square e to the minus 3t. I can take out e to the minus 3t from the first column and again from the second column, and the product e to the minus 3t times e to the minus 3t is e to the minus 6t. The remaining part is t here, 1 here, 1 minus 3t here, and negative 3 here. So this is minus t square e to the minus 3t numerator, e to the minus 6t times minus 3t minus 1 plus 3t. So minus 3t plus 3t cancels out. E to the minus 3t divided by e to the minus 6t is e to the minus 3 plus 3, plus 6, so it is plus 3, so we get minus t square e to the 3t. Correct? And there is another minus here, so plus t square e to the minus 3t. Okay? Let me just keep the result of the Wronskian calculation. So the Wronskian of t to the minus 3t and e to the minus 3t is computed here is minus e to the minus 6t. Okay, so I'm going to erase this. This is t square e to the 3t. And now I'm going to compute u2 prime in the same manner. Right? So it's still the ratio of two determinants. The bottom determinant is the same as the Wronskian determinant. Is t e to the minus 3t, e to the minus 3t, t e to the minus 3t prime, e to the minus 3t prime. And the top determinant is obtained from the bottom determinant by replacing, since it's the second variable, we need to replace the second column with the right hand side. So the first column remains the same, t. And the second column becomes the right hand side, 0 t squared. Now this is easier because we have already computed the Wronskian. So the denominator is the Wronskian, is minus e to the minus 6t. And the numerator is this times this. So this is t cubed e to the minus 3t. And this is just, minus t cubed e to the 3t.